Welcome back, everybody, to the CONEXPO-CON podcast. I am your host, as always, Taylor White. Last couple episodes, I first of all want to thank everybody for listening to. Everybody's been giving a lot of good feedback, and that is awesome. With me here today, I actually have a guest, and we have Andrew Schiller here with me from Utah Tech University. And this is somebody who's definitely way smarter than me, more qualified, that's for sure. He's actually been to CONEXPO, and he was actually in an article with CONEXPO because he brought his students to the actual show, which is really cool. So, Andrew, thanks for being here with us.
Thanks, Taylor.
So you have an engineering background and you teach at Utah Tech University.
Well, I'm a bit of a weird bird in our engineering department because I don't have a PhD. So I have a background in engineering, spent almost 9 years in the field, and then saw this opportunity, which is kind of right up my alley. It's some stuff that I love, I'm excited about, and I get to work with students. So I really enjoy it.
So what exactly do you teach? Like, what is your course? Like, what do you teach your students?
The heart of what I kind of do here is courses related to manufacturing and product design. So how are things made in the real world? And then how do you train a student to go from an idea in their head to a professional design using professional CAD software to an actual prototype product or a product that's ready for production? A lot of times students have really cool ideas and they're very creative, but what they lack is a bit of a realistic understanding of how do I actually make something, you know?
So what got you into, I guess, kind of interested in what you're doing now? Like what happened when you were younger that was like, this is what I want to do?
Yeah, that's a really good question. I probably since mid high school, I knew I wanted to go into engineering because I loved making things. That's really as simple as it was. Played with a lot of Legos as a kid, and I was fortunate. My dad has a shop attached to the house that he works out of, and he's a model maker, so kind of an artist, but he's got a mill and a lathe, and I spent a ton of time learning the basics of manual machining and just learn how to make things. So I do all kinds of projects and things like that. And then in college, got a generic mechanical engineering degree, but really hung out in our fabrication lab in college, made a lot of stuff, worked for them for 3 years. So that kind of became like, I love this. I really enjoy it.
What are you seeing with, I guess, the new students, the next generation that seem kind of interested in this industry? And whether it be, I know you're teaching manufacturing and stuff, but like, what are you seeing, in the next generation?
I think a lot of students come into engineering in a university setting. A lot of students come into an engineering program, maybe a little bit similar to me. Like, I like to make stuff. I can design some things. And sometimes in a university, the picture of engineering that we give can be a little bit unrealistic in the sense that, students are in classes like thermodynamics and heat transfer and CFD, or all of these very conceptually kind of math heavy courses. And those are awesome. Like, don't get me wrong. But students sometimes get the impression that engineering is going to be kind of boring, kind of me sitting in a computer doing complex math, and one of the things that I love about my job that I get to do is sort of introduce students to the world of engineering and try to give them a more realistic picture of what it is. So even I teach a lecture it's a broad overview of manufacturing processes and management. And even in that course, we cover everything from how atoms move in a crystal lattice in a piece of metal while it's being deformed to biggest picture, how do you manage a manufacturing plant? We talk about the Toyota production system. We talk about industrial design and the importance of coatings and appearance, and something most engineers usually aren't thinking about. It's like, oh, this has to look a certain way too. It's a chance to introduce engineering students to kind of the broad variety of things that you can do as an engineer. If you want to be really math heavy, do a lot of programming, you can, that's great. But if you are much more of a people person and you want to be a technical expert in a very particular thing, you can get into being the expert in that and kind of supporting your company's customers and working with people. And or you can get into sales and be a sales engineer, or you can get into industrial design if you're more kind of artistic. But all of it, you have to have some realistic understanding of how things are made or how the process works. So yeah, I think to answer your question, one of the trends I see is, and it's not really new, I suppose, but students coming in, I like to make stuff. I think I should maybe go into engineering. And sometimes they get the impression that, oh, actually, this isn't really hands-on, but in reality, it can be very hands-on or very exciting.
No, it's really cool because you're kind of like giving people different bit of an outlook on like, okay, maybe showing them the different options with engineering. But it was really cool. You were talking about, like you were looking at Toyota's manufacturing lineup and stuff. What do you think of my buddy recently just got a Cybertruck and he loves it and he thinks it's really cool. What do you think? Have you like looked into like Tesla's production line, or they're like, because like I feel like Elon is like ahead of his time, maybe just from what I see, but I'm not in the industry of like what he's doing to manufacture. And the Cybertruck is actually like the biggest press machine, and it's like one piece. What's your opinion on that?
It's amazing. We do talk about Tesla in a few specific instances. Tesla's a really interesting example, actually, coming from someone who teaches manufacturing. So, for example, like when they kicked off their Model S production, I think it was around 2016, they had a ton of trouble. Wasn't working out right, and they had to change the way that they set up their factory quite quickly. And Elon, there's a quote that I've seen from him, and he said, the level to which we used automation in the production of the Model S was a mistake. And to be clear, it was my mistake. People are invaluable. One of the things that we use that for as an example during classes, as an engineer getting into manufacturing, maybe if you're getting into manufacturing, your tendency is to think, I like robots. Robots are awesome. Let's automate everything. Let's buy the most awesome way of doing everything. And that's not necessarily always true. You have to be wise about how you apply these tools and these solutions. Now, Tesla's doing some amazing things with the way that cars are made on the automation side, also just on the design side. They have, for example, in some of their current models, the die casting industry has experienced some significant, I want to say growth, maybe developments in recent years, so that there are some Tesla models that have a front and a rear frame component that's a die cast aluminum part, but it's huge. They have these die casting machines that'll apply like 16,000 tons of pressure to these two dies, and they can make very large single piece castings. And I believe it's in the back of the Model S, they're using this die casting for the rear of the frame, and they're replacing something like 320 individual parts with a single casting. Volvo's kind of jumped onto that. Ford is working on that right now, but like that's going to change the way that cars are designed and manufactured, and ultimately like make them more accessible and inexpensive.
I think it's and I always hear Elon talk about like manufacturing at scale is one of the hardest things ever. And that's kind of what he stresses is like, I can make some cars, but make a lot of cars is more difficult. And I think that's what's really interesting. And I guess where my mind goes when you're talking about that is like, have you ever looked into or have any input on, like cat production plants or like heavy machinery manufacturing? Because I myself personally, I just bought a D5 dozer. And one of the deals was I was like, I want to go down to the plant where they make them. And I believe it's North Carolina or South Carolina.
I think it's in South Carolina. Yeah.
Yes. And I really want to go check it out, and because that to me is so neat. And like, I just see little snippets online of it, but I'd love to like, have you ever looked into, I guess, that kind of manufacturing, the heavy machinery?
Yeah. It's similar to the automotive world, but it's probably honestly what I'm more familiar with. So I spent 6 years working for CAT. So I was an engineer there for 6 years in Illinois.
No way. What'd you work on?
I did starters and alternators. So your product starts and can charge a battery. There were 3 guys, including me, on a little team, and we managed all of the starting motors and alternators on, I believe it was 6 or 7 liter engines and larger.
Wow, think about that. They had a team dedicated to starters and alternators.
I know, right? So the 3 of us were responsible for not designing the product or manufacturing the product, but working with there's actually not a lot of global players in the commercial starter and alternator business. There's really 7, 8, maybe 9 that are doing real, they're not just copying designs from each other. There are lots of little places that will just copy a design and then sell it. But there are 7 or 8 suppliers that we work with. I was responsible for our relationship with Bosch that became SEG in Germany, Mala in Slovenia. They produce out of Slovenia, and then Denso in Japan. So our team, the 3 of us, we managed, I think it was anywhere from $80 to $90 million a year in product, depending on how CAT was doing. They buy a lot of starters and alternators.
I guess so.
And then we would essentially, our job was to offer a portfolio of starters and alternators to the various product groups at Caterpillar and help them get the product that they needed for their application and make sure they're using it right, things like that. Caterpillar has a lot of, they have 300 to 400 different product groups. So it's not just dozers and excavating equipment, stuff like that. They're in mining and forestry and all kinds of other things. So that was our job. And then we would tour manufacturing facilities, both within Caterpillar to make sure that they're installing this product correctly, they're handling it correctly, they're not painting on the flange that it's mounted on, for example. And then we would tour manufacturing facilities. So I several times have been to Germany and Slovenia touring those facilities and helping them produce product in a way that met sort of our requirements.
There's some big plants over there, right?
There are some huge plants over there. Yeah. But to answer your question about Caterpillar, they're sort of automotive in the way that they do it. Most of the employees at least in Illinois, in the facilities are actually auto workers union employees. It's super interesting. It's sort of an automotive setting, but obviously their volume is not as high, so they can't do everything that the automotive world does. One of the unique things that they do, at least in Peoria, where they produce, I believe it's the D6 or D7 and above, the whole machine is on this, essentially on a robot, and then it drives to various stations.
With the machine on it?
Yeah, it's basically a platform. Everything up to the D11 is produced there. And so you can have this giant machine on a big platform just driving around the factory, and it'll just go to the next station, and then the people at that station will do what they need to do with it, and then it goes to the next station. And super neat way of controlling flow in a manufacturing facility. Eventually, after they put the tracks on, then they just drive the machine around, but super cool.
What was the most complex part when you were at Caterpillar of the production of machinery?
Wow, that's a big question. Most complex, like piece part, or most complex aspect of?
Yeah, I don't know. You're right. Like, I don't know. Like when I think complex, I think like what was the most like, okay, so much time went into the engineering of this. So much time has to go into make sure this part is perfect.
I mean, that's surprisingly true for just about everything that goes into the machine. The first thing that comes to mind is the ECM or the different engine control modules that are on the machine. Those guys are like another level of engineer. It's nuts.
They wouldn't be able to talk on the podcast.
Oh, it would be. I mean, I had a few conversations with some of our ECM guys about how they control the starting motor, for example. And they're talking about, these 120 pin connectors, and they're like, oh, well, this pin can provide this much current, and this one is, and I got to look into the code for this. And I'm like, what are you talking about? Really cool. And I'm glad there's experts that they have to know that, right? But just an insane level of detail and care and attention that goes into programming those ECMs. It's nuts.
That's really cool. Do you see anything like with the technology, I guess, coming out now, more AI? Is AI something that the manufacturing world or, these machinery or even the students, I guess, that you're teaching, are any of them worried about it? Like, will I be replaced? Can I be replaced?
Yeah, that's a huge question. And the people who are currently most concerned about AI are generally the people who do a lot of writing. And there's other areas too, but because AI is so at writing, it's still pretty noticeable, at least for me. Like I have students submit stuff that's purely written by AI sometimes. And I've said to students like, hey, don't do that again. And, their grade will reflect that. But that is a huge question. Like, how is AI changing both education on my end and then, for a company like Caterpillar or an equipment manufacturer, or even for you, for what you do? Where do I start? So as a university, our desire is to fully kind of embrace what AI can do. I don't want students who don't know how to write an email because they, literally don't know how to write. I want students to write, but I also want students to use this amazing tool and know how to use it. And AI currently in the world of engineering, like it's a little bit, there's not a whole lot that you can do as far as like getting it to design something for you, because you still have to know that it's safe. But that's changing. So I think one of the things that AI is going to help the world of engineering with is when you're designing a product, maybe there will be ways to know how things have been designed already so that you can kind of stand on someone's shoulders and reach farther than you could on your own. I think AI is an amazing learning tool. I've used it even to gather information. Sometimes the information is wrong when you get pretty technical and detailed, but you have to parse through it, right? I've used it for ideas. Hey, I'm going to have my students listen to a podcast episode about machining, for example, for one class. And I said, hey, give me some ideas for an assignment that's related to engineering students at a university. They listen to a podcast and then they do some assignment based on that. Super good ideas, right? And you tweak some things and then you take it. There's a really cool company right now. I don't know if you're familiar with machining. That's kind of my wheelhouse right now. There's a very cool company called Toolpath Labs, and they have an AI tool that's sort of tied with Fusion 360, which is a computer-aided manufacturing software that we use to program toolpaths on a CNC milling machine or a lathe. And it's an AI tool. You tell it what your tool library is. You kind of set that up, and then you can load a 3D model in there, and it will tell you can machine this or you can't machine this, and here are the features you can't machine. It'll tell you all the setups you need and what each tool is doing. And then they have a feature that will allow you to just export that into Fusion, and boom, there's all your programming, there's all your toolpaths. So I was using it the other week and took what would probably be 45, 50 minutes of work and made it 5 minutes. You still have to check over some things, but it's awesome. So on the AI side, there's a lot of fascinating stuff in education. In construction and kind of heavy equipment, you're probably aware there are entire mine sites that run Caterpillar equipment or Liebherr equipment where the trucks are autonomous. Sometimes excavation is autonomous. That's not so much AI. It's a lot of just algorithms, but still really neat application of that stuff. What is exciting for me and maybe more for you is maybe I have an autonomous excavator where I just tell it, hey, I want this, and it'll go and dig it. I was working, and I don't know if this is still a program at Caterpillar, but I was working with friends with a gentleman at Caterpillar who was working on an attachment for an excavator that would essentially extrude concrete. And so you could have an autonomous excavator that goes in and digs the foundation, and then essentially using the excavator as a 3D printer to print a foundation around itself. So super neat application of kind of high level technology in a pretty regular setting like a construction site,
That's really neat.
Yeah, super neat. I think that program has since kind of shifted focus, or there are other companies doing, printing in concrete, things like that.
No, that's really cool. I mean, what's neat is you talk about how you're using it, even at the university, but me using it as a business owner, an employer or whoever, like there's times where like we'll get big tender documents that are 300-400 pages. I can upload that to ChatGPT and say, look for keywords of contaminated soil, bedrock.
Whoa, that's amazing.
Yeah, exactly. And you know what it is though, Andrew, is it's like, I even just had conversations with some buddies that own some businesses down in the States, and we were just like, what are you guys using AI for? And one guy was like, I just did a purchase deal agreement for another business and it got written up through ChatGPT. I'm like, wow, that's crazy. And he goes, well, we're doing takeoffs for manhole covers and catch basins through ChatGPT because we tell them to. And it's just the possibilities are, to me, so endless. And then uploading a document and saving it. So now my estimator has more free time to start doing the takeoff of, okay, the different elevations and grades. But then I think, when is, a company like Bid and to Win or Ag Pro or Trimble, when they start really integrating with AI and we're able to get a set of CAD drawings and go, shoop, do my takeoff. That is going to make the market for excavation or construction so competitive because everybody's going to have the exact same amount of material, which is really cool. Essentially, like I was saying to my estimator, he's like, well, I'm working myself out of a job. I'm like, well, no, all it does is I want to bid more work. So my dream is to, get a junior estimator underneath him. But it eliminates possibly the need for a junior estimator, because the stuff that you would be getting a junior estimator to doing, if AI can handle that and you can just oversee, then that's really cool. But even day to day, business, emails, like I got this email from a client who was upset about this, like, would be my response. What do you think about that? And it almost is like, okay, give a better approach.
Like a sounding board.
Yeah.
Yeah.
Yeah. It's like my therapist almost sometimes, like, oh, take a deep breath. It's like, oh, okay. I think it's really exciting, and I am almost scared just to see where AI is going to go in 5 years, and specifically in the construction industry, because that's what I'm excited about. But like you said, why is there no reason that, I put an excavator on a job site, because everyone's like, oh, you can't use, autonomy on a residential job site. It's like, okay, but that was 3 years ago before ChatGPT and people were thinking about AI. But now, what if I had an excavator? I drop it off there. We upload all the CAD files. It's integrated with Trimble, and we say, complete this job. And it knows the job site. It digs the foundation. It knows how to backfill. It knows the materials on site. It goes and scoops the proper material. Like, really, that sounds, 5 years ago, you would have sounded like you were on an episode of Star Wars talking about that. But now it's like, no, that actually probably is achievable.
Yeah. And even the excavator could recognize if someone walked into the job site and it could stop.
Well, it does now. Like some of our machinery, if you walk behind it, an alarm goes off in the machine. We have 360, views of like the stuff that the rate of technology with everything is so crazy. And I think that's where I'm so excited with the construction industry. And before even, it's crazy because ChatGPT and AI, like this conversation really started a couple of years ago. It's really been hyping up over the last year, at least in our industry. But like talking to other people about technology, it always was like, oh yeah, Trimble, they're really good, the GPS stuff. And now it's like, AI, where's AI going to take us with this GPS and Trimble and technology like TopCon and Leica and all that?
It's amazing. That's amazing.
It's really neat. It's really neat. And I think that's what's interesting on your part, is seeing how it's integrating with what you're doing. And I think that's just really cool. And I think that it's neat for the students, especially coming into the industry, to see the possibilities and not so much looking at it like, well, this can replace me, but how can I use this and how can I benefit from this and how can my job actually benefit from this?
And honestly, like change the world. To tie this into your original question about trends in college students, a lot of engineering students come into school and maybe without saying it, they have the impression that if I'm not building parts that go into space, it's boring. And that's fine. If you want to work in aerospace, that's awesome. It's a really cool field. But a guy like you is building houses or building buildings, and like you're making the world happen. And as an engineer, like how cool is it to come up with these new technologies that really change the world? That's awesome.
Yeah, I totally agree.
I started a lecture last week in a class about manufacturing. I brought up two pictures, and one was a picture of like some fancy Lamborghini, and the other one was a Honda Civic. And I said, okay, I want to ask you a question. If you're going to spend your career designing one of these products, which one would you rather? And most students are like, oh, the Lamborghini, that's cool, right? I said, okay, let me ask that question again, different way. Would you rather spend your career designing a really cool toy for a few rich people, or a product that millions of people are going to use every day to get to work and live their life? You ask the question that way and the answer is kind of obvious. But yeah, a lot of students, like, they think, oh man, if I'm not at this super cool company, if I'm not at SpaceX, if I'm not at Blue Origin, what am I doing? And like, I don't know. I worked at CAT on starters and alternators, which seems kind of boring, but I was fascinated by. And at the end of the day, like there's tens of thousands of guys like you who every day you depend on these products to start and charge a battery and do what you do, right? Like that's really cool.
Guys like me that use the product that you worked on essentially every day, and we rely on it to start our machinery and to start our stuff. Who wants to run a 90 ton? Who wants to run a 390? And who wants to run a 15 ton? I guarantee you everybody in the room would be like, well, I want to run
the 390 is way more fun. But yeah.
Exactly. But okay, well, there's less 390s in the world and more 315s. And the 390, the job that the 390 is on, it's probably staying there for a year minimum or 6 months minimum. And you're baling dirt and you're loading a rock truck every day. The 315, I explain this to my guys, is, you're on a different job site probably every 5 days. It's a more kind of technical machine. your tighter areas, you're doing swaling, drainage work, you have a grading bucket, or a rototilt and so it's kind of the same thing. It's like, and a lot of the guys, once you explain it like that, it's like, oh yeah, you're right. I always tell my guys, they always like, oh, we got to get into, bigger machinery and bigger this. I'm like, trust me, I do too. I'm not saying that that's not cool. But what I am saying is that I know how all you guys get when we're on a job site for like a long job site for us would be 4 weeks. And by the end of the 4 weeks, they're all like, okay, man, we're ready for the next one. Like, let's get off this and move to the next. And I kind of explain, I'm like, well, when you're on that bigger machinery, you're not moving a 90-ton excavator every 3 weeks. You just wouldn't be doing that. So I think that it's kind of the same way. And I find that in the next generation as well, too. I don't know. There's almost a sense of which is good, a sense of like, I'm not content where I am and I want to keep pushing. And that's good. But I think there's also a sense of just they see with like social media and what they see online and what they're told is really cool. And they kind of have this sense of expectation versus reality. I think that that's really important for the next generation right now to understand that expectations are not reality. It's great to have those expectations and hopes and dreams, trust me, or else we would not all be where we are. But you have to remember what reality is.
I think everybody wants to be doing something meaningful, and they want to be doing something that feels important. And often what you're saying, like the reality of that is different from the expectation of that. Being an expert at running a smaller excavator like a 315, that's a very important thing. You're helping build houses, you're helping build little commercial things or whatever. Like, it's also important to know how to run a 390, but like people think, oh, it's bigger, it's more flashy, that's what I want to do. And in reality, it's like, no, you want to help the world be a better place. So think about that.
Yeah. No, I totally agree. You took one of your classes to CONEXPO. How was that experience? And what did the students kind of like, what was their take back?
My motive in doing that is part of what we've been talking about a little bit. Like, students have a somewhat limited understanding of like, here's what it would look like to be an engineer. And from working at Caterpillar and just from life, I know like there's a ridiculous amount of engineering and design work that goes into this kind of equipment. So my hope in doing that and really goal was to expose students to these companies and this equipment and say, hey, this is the kind of place you could work for, So students loved it. I mean, ConAg is just impressive in itself. There's all kinds of wild stuff there, huge things, small things that are all really cool. It's amazing. And we only had like 6 hours there. It was not enough time at all.
No, I spent 3 days. I didn't see the whole thing.
Right. But it was really neat. Right. And there's some really cool stuff Volvo's doing. Really, we spent a lot of time with Volvo and Caterpillar, like looking at some of their stuff. And so, yeah, my hope was really to show our students kind of how cool this stuff is. And even from an engineer's point of view, like you could have a really cool career making this equipment better and building it. And how do you manufacture it? How do you design it? How does it work? What new ways can you use it? And that's true on the high end, all the way up from like the biggest cranes that they had there down to there were entire booths there that were just seals. How you seal things, right? And there's engineers that have meaningful, fulfilling careers working on seals and helping companies solve problems related to sealing,
You're right. It is so neat. And like, you're so right. And I think what's really neat is that, and hopefully people listening to this podcast, it's like guys, especially like me, we don't realize how much back end stuff or engineering goes into us turning the master on in the morning, flipping the key over and turning on the machine. Just how much engineering went into being able to just do that is wild.
Yeah, it's nuts. And the fact that, a lot of these construction equipment, mining equipment, like the kinds of conditions that it's working in are horrible conditions for a mechanized piece of machinery, right? But it's working every day on the reg, there's so much that goes into making that happen. At CAT, there's a picture that kind of went around. It was a 797, so big 400-ton off-highway truck, they call it, but a big mining truck. And it had been left in the bottom of a mine or a quarry during a big rainstorm. And the whole thing filled up with water up to almost the top of the bed. So the whole thing's underwater. And they had to let this thing like pump water out of it or let it dry out, whatever. And at the end of it, started it up, drove it out. And like, it's not supposed to do that.
It's good that it did.
That's what it does. Or there was another picture of I think it was a D7 pushing a pile of salt in about 3 feet of water in the Dead Sea. And just the most corrosive environment you can possibly imagine, right? It's hot, salty, wet. And this is just the regular environment that this thing operates in. And we had to design a product that could do that, or create offer a product that could do that. It's amazing some of the conditions that these things operate in.
It is. And, I'm glad. And hopefully on this podcast, people got to hear a different perspective from the engineering standpoint of it, because we get to talk to a lot of business owners or a lot of operators. And I think that's really cool. And I think what you're doing is really needed. We need more people that are kind of showing the industry, but also talking about and being vocal about the back end stuff of how everything works and how we're able to go and do our jobs every day. So I very much appreciate you coming on today's podcast, Andrew, and sharing with us that. And I wish you, all the best in the future. And hopefully next year, March 2026, you bring another student class trip to CONEXPO.
I'm planning on it. This trip was sort of last minute. Not so much last minute, but more unofficial. I would love to get a big bus from the university and bring, 50 students down or something.
All right, Andrew, appreciate it. Thanks for coming on, man.
Taylor, thanks so much.
Thanks everybody for listening to the CONEXPO-CON podcast. Have a good one.